Okay, so in this problem here, we are asked to state the new domain and range of the following using interval notation. So if I have a function f of x, and that x is all real numbers and y is bigger than or equal to 0, and it undergoes the transformation of y equals f of negative. Well, we have to read this transformation, and this is saying all the y values change. So that means x and y will go to x, the y values get negative, and so it is a reflection over the x-axis. All the y's change. So if I think about what this means, if I have some graph here, this says y is bigger than or equal to 0, so it could be something crazy that just goes here, like that. And if I reflect it over the axis, well, I'm sure it's going to be something like this and like that, scribbled. But this is the value that remains the same, but in the opposite direction. And these continue to go off forever. So the domain is going to be simply from all real numbers. And the range, though, is going to change. It's going to go from 0 to negative infinity. So it's going to go from 0, including 0, to negative infinity, is what that's going to happen there, because this is a reflection over the x-axis. Okay, look at B part now. If x squared minus 9y undergoes this transformation, well, we know this is over the x-axis, and this one is over the y-axis. So if I think about x squared minus 9, I know x squared is this graph here. Minus 9 means it's going to be shifted down. This is a translation down 9. So here is my graph. And you could graph it on your calculator if you're unsure what that looks like. But if I take this point, let's say this point here is here I know this point is actually 1, 8, and this is, so if I take it and I reflect 1, 8 over the y-axis, it goes to here to negative 1, negative 8, which are both negative 8. And so this just goes to itself. Similarly, that will go to itself. And so for the transformation over the y-axis, it doesn't change anything. The x-axis will mean this will end up upside down. And these values here will be invariant. The x-intercepts will be invariant when we do both of them, of these transformations. So if I do the replacement says, well, here's my mapping notation, right? It's going to go to negative x and negative y. And so replacement means u equals minus x, and so x equals minus u. I'm going to replace the x with a negative x, and v will be minus y, and y will be minus v. And so when I substitute these values in, I get minus v, which is y, equal to minus u, which is x squared minus 9. This is minus y is equal to x squared minus 9, and then multiply by negative y is negative x squared plus 9. This is the new transformed image. And so this here, if I kind of sneak in, technically this is the mapping notation, and then I'm going to replace x with minus x and y with minus y is what this is all saying. Okay, and this is the equation we get. Let's take a look at another scenario where we're given a graph to do the transformation. And again, I know that this is over the y-axis, and this is over the x-axis. And so I know that my x and y, or u and v, will change to negative x and negative y exactly. So if I look at these 3 points here, which are great ideas of critical points, my new minus f minus x graph, both x and y change, so that'll be 3 comma 0. So negative 3 will end up being a positive 3, and I reflect it over itself. 0, negative 4, the y changes, so that will end up down here. And finally, negative 1, positive 2, negative 1, and positive 2. And so if I connect these up here and here, and for as invariant points, clearly we can see there are none.